Hi, welcome to NewTech YouTube channel. In this video, we are going to study and solve example on Thevenin's theorem. Let's begin. The Thevenin's theorem is used with linear and bilateral circuits. Now, let's study some key terms. First key term, bilateral circuit statement. This type of circuit allows the current flow in both directions. Second key term, Vth statement, open circuit voltage at the terminals. Third key term, Rth statement, input or equivalent resistance at the network or circuit terminals when the independent sources are turned off. We just studied some important key terms. Now let's study statement of Thevenin's theorem as statement. A linear and bilateral two-terminal network can be replaced by an equivalent network consisting of a voltage source connected in series with a resistor. Means we get simplified network with voltage source and a series resistor. Let's understand circuit representation using Thevenin's theorem. A given linear and bilateral network with load can be replaced by an Thevenin's equivalent circuit as open circuit voltage or Thevenin's voltage Vth in series with Thevenin's resistance Rth along with load resistor RL. Up till now, we have studied important key terms, statement of Thevenin's theorem, and circuit representation of the same. Let's study procedure of Thevenin's theorem. Step 1. Remove the load in a given network or circuit and label the terminals as A and B. Procedure. Step 2. Calculate the open circuit voltage Vth at the load terminals after disconnecting the load resistance RL. Here, in general, one can apply any one of the techniques such as mesh analysis, node analysis, and superposition theorem, etc., which are studied earlier. Procedure. Step 3. Calculate the resistance that would exist between the load terminals at A and B, that is, if it is a voltage source, short circuit it, or if it is a current source, open circuit the same. Procedure. Step 4. Draw new Thevenin's equivalent circuit using Vth, Rth and RL. Using procedure of Thevenin's theorem, let's solve example on the same example statement. Use the Thevenin's equivalent circuit to calculate the current through load resistor RL. Let's see given data. Voltage source is equal to 15 volt, resistor R1 is equal to 6 kilo ohm, resistor R2 is equal to 2 kilo ohm, and load resistor RL is equal to 5 kilo ohm. Now find current through load resistor RL. Solution. Step 1. Remove load RL and label the terminals as A and B. Let's see the diagram. We have removed the load RL and labeled the terminals as A and B. Solution. Step 2. Calculate the open circuit voltage at the load terminals as a Vth. Refer the diagram. We are measuring open circuit voltage Vth across the resistor R2 at the terminals A and B. Now refer previously studied diagram. Using voltage division rule at resistor R2 as open circuit voltage Vth is equal to resistor R2 divided by resistor R1 plus R2 into voltage source Vs. Substitute values of R1, R2 and Vs as 2 kilo ohm, 6 kilo ohm and 15 volt respectively into a given equation, we get value of open circuit voltage Vth is equal to 3.75 volt. Solution. Step 3. Calculate the resistance that would exist between the load terminals at A and B, that is resistance Rth, as we are finding equivalent resistance of a given circuit with independent sources are turned off. In given circuit, voltage source Vs is short circuited and then obtained equivalent resistance Rth at the terminals A and B where load RL is removed. With reference to previously studied diagram, find Thevenin's equivalent resistance Rth as where resistor R1 and R2 are in parallel. Therefore, Rth is equal to R1 into R2 divided by R1 plus R2. Substitute values of resistor R1 is equal to 2 kilo ohm and resistor R2 is equal to 6 kilo ohm. We get Thevenin's equivalent resistance Rth is equal to 1.5 kilo ohm. Solution. Step 4. Here we have drawn Thevenin's equivalent circuit using value of open circuit voltage Vth, equivalent resistance Rth and load resistance RL. Then find load current IL as using Thevenin's equivalent circuit. Formula of load current RL is equal to open circuit voltage Vth divided by Rth upon RL. Substitute value of Vth, Rth and RL as 3.75 volt, 1.5 kilo ohm and 5 kilo ohm respectively. After calculation, value of load current IL is equal to 0.5769 milliampere, and this is our required result. In this video, we have studied theory and solved example on Thevenin's theorem. Thanks for watching my YouTube channel. Thank you.